Hello everyone, this is Unit 3, Lesson 4. We're going to be talking about constants and variable scope. So whenever we talk about variables, we talk about the scope, meaning where can the variable be used. So a variable with global scope is defined outside of a function. And a function, we can think of it as anything that doesn't have the open and curly braces. Local scope is defined within the curly braces. So for example, here, this variable, global variable, the name of it, global variable, is assigned to true. It's a Boolean and it has a global scope. And this constant here, called local variable, has a local scope. So if we look at this example, going back to this example, if I try to print local variable outside of the if statement, so right here where my pointer is, it's going to give me an error. Let me see, I think I was playing with this earlier. Okay, so I'm just going to start an empty playground so we can see some of this, how it functions. The easiest way to learn this is to actually create some variables. So here I'm going to say if true, then let local equals 7. So local equals 7. And basically here it's saying that I'm initializing this variable local, but I'm not using it. So I can say print local. And if I do that, it looks like I'm running out of battery. Okay, so if I print local, so this string here has hello playground. This local variable has a 7. I can print the 7 here. If I try to print local there, it's going to give me an error and it's going to say use of unresolved identifier local. So it does not understand, it doesn't know that local has been defined because it's been defined inside the curly braces. Now with string, I can print string here, and I can print string here because it's a global variable. And global variables can be used anywhere in my program. This here is just telling me that I initialized local, but I haven't used it. It's just a warning. That's not a big deal. Okay, so I initialized local to 7. I didn't use it. It gives me a warning. It prints the string hello playground. Prints the string hello playground because it's a global variable. So here we have variable age equals 55. We have a function to print my age. We print the global variable age, and then we say print age. So when I say print age, it goes to the location where age is and it prints the value of it. And when I call the function print my age, it just goes inside the function and it prints my age :space 55. And that's my output. So here it's just showing you you're using a global variable for a function. which we typically don't do. Typically when we write functions, we keep all our variables as local variables because we don't want our variables to get the value to get changed by mistake, especially when you're working in really big programs. And I mean, some of these programs that you work in are just thousands and thousands of lines, and many, 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 many different pieces are put together. Think of these huge programs that, just something as simple as going to the grocery store and purchasing something. That point of sale system has so many pieces. So you don't want to have a global variable and then somebody else in another part of the program changes the value of your global variable. You always want to keep them local. You always want to pass values to functions. And the only time that we use something that's global, it's when we create constants. Constants that are used by all the programmers that are working on one application. So for example, like, the address, let's say this is some application that's going to print the address and the name of a store. So the name and the address, that can be a constant that's saved somewhere in some header, but not variables like this that you just don't want to do that. Okay, so here we have bottle count. It is local because we defined it inside the curly braces. Again, we can print it inside. We can call the function print bottle count. It goes in here and it prints the 99, but we can't print the constant bottle count. It's going to give us an error. It's going to say use of unresolved identifier bottle count, which is what we just did in that example that I did on Playground. This is a function that has a variable name assigned Richard. Here we created the variable index. The variable index is gonna have the values from 1 to 10, and this for loop is going to print the index 1 to 10 and the name Richard. So basically it's going to print 1 Richard, 2 Richard, 3 Richard. So that works all okay. If we try to print the index outside of the for loop, so at this point it would be 10, then it says use of unresolved identifier index. It can't print it because index was defined here. It can print name without a problem because it's a global variable. And actually it's not global. Name is local to this function. We're within the function, so we can print it. And then here we can call the function print 10 names, and it prints 1 Richard, 2 Richard, 3 Richard, so on and so forth. Okay. Hopefully that makes sense, but what we can do is we can copy the code and we can put it here. And what I'm going to do is I'm going to take out the print index out. So it says 1 Richard, 2 Richard, 3 Richard. Our for loop takes us all the way to 10, so it takes us from 1 to 10. Once the for loop stops, it prints the name again, Richard, but I can't print index. So if I try to print index, it It does not print index. It doesn't print the value of index. And I'm not, yeah, and this just calls our function. So we call the function, it does this, it tries to print index, and then print name, print Richard. Okay, so here, variable shadowing. So we have points, this is a constant, it equals 100. We define index, it's going to have the values 1 to 3. Then in here we have another constant called points. This constant has the value of 200. So inside the loop, I'm going around 3 times. I print 1 points plus index, so 200 plus 1, 200 plus 2, 200 plus 3. So it prints this, this, and this. That's this local constant in here. Boop. This one on the outside, this constant on the outside stays 100. This does not mess with this one. So this one on the outside, when we print it, it stays as 100. So what's happening here is that when you create this constant, the compiler is going to grab some memory, and it's going to have that memory is going to save the 100. So there's a memory address for this constant, and there's a separate memory address for this constant. So these two variables named points, they don't live in the same house. They have different addresses, totally separate houses. We talked a little bit about memory locations before. So you can think of a memory location as a house. You know, I live at my house and my name is Jeanette, and maybe my neighbor's name is Jeanette also, but we're two different people. Whatever I do, you know, whatever I do to myself will be different what my neighbor does for or to herself. And so these have completely different memory addresses. This can be very confusing, so it's best to use different variable names. Okay? So let's see this one run. Let. Okay. So we'll run it. So the inside loop runs 3 times. This is 100. This stays 100. But the inside points go from 201, 202, 203. So it's probably better just to name this something else, like you could name it P, and this one then could be P, and then that makes it less confusing. Same output. Okay, next slide. Now, sometimes we do want to have variable shadowing when we use optional values. So we talked about, the last section we talked about was optional values. So if you remember, if at the end of a data type you put a question mark, it means that this variable name could or could not have a string, right? So it could be a nil or it could be an actual string. So that's what the question mark means. It could be a nil or it could be a string. And then we said also in the last video, we said that when we do something like this, let name equals name, is that we're unwrapping the variable. So this will only return true if it's not a nil. So if it's not a nil, it will print name, because remember that if it's a nil, it would give us an error, it would mess up our program. So here we're creating a separate variable, separate constant named name. This is a variable named name that has one address. This is a constant named name that has a different address. And we assign it name, and then we print the name if it has one. So